Thanks, Kevin. Thanks a lot. How are you guys doing today? Tired? Not yet? Coffee time? No? Cool. So my name is Nitin Motgi. I'm the founder and CTO of Cask. Yeah, they also call me in office called Jolty Neutrino for some reason. It's kind of funny. I used to, prior to starting this company, I was at FedEx, Altera, and anyone from UCF here? Central Florida? Okay. And I was Altera and Yahoo for quite some time. And my current job is to run behind these elephants, if you know what I mean. It's basically working with Hadoop and trying to tame them in as much as I can. So today we are going to be talking about the platform that we have been building for about 3 years. A little bit background to why this platform came into existence. So I was at Yahoo running front page of Yahoo, not necessarily serving the pages out, but optimizing the content of the pages. So we were at the point when we started building content optimization on front page of Yahoo. It had 300 million page views a day, 50 million users coming in and accessing that site. It was kind of a fire hose. And being able to take that much amount of content and that much amount of raw data and being able to process it and target it was a huge effort. So we started building the whole infrastructure on Hadoop in 2007. So early days of HDFS and MapReduce, and then slowly we moved to using HBase. So by the time when we ended up, we had around 28 data centers where we were serving the same amount of traffic directly from HBase, and then being able to optimize the content at a very personal level. That means you could identify what you did for a quite a long period. I mean, it's not like you can tie it to an individual, but it's like you can basically see the history of a given ID for quite a long period of time. So the problem that existed then was because Hadoop had started evolving within Yahoo, there are a lot of technologies that were being built. There are a lot of tooling that was built within Yahoo itself for doing the same stuff. So there was no harmony in how the solutions were being built. There was no standardization. Like a data scientist would come in and write something in Python and expect it to be moved to production in no time. Someone would do it in R and expect it to be moved to production in no time. So it was kind of difficult to be able to have a consistent platform that allowed us to move something from the lab into production, right? So that's where we decided to build a standardized platform, a common platform that was mainly allowing the data scientists to do experimentations and move them into production as fast as they can. So that's where we realized this is great. I mean, we had 45 systems engineers who were trying to build this, and we were successful doing it. We were able to take something that is being built in lab and moving into production in about 15 minutes. So it ended up being, we used to do 15, 16 experiments a day on front page of Yahoo. So it was huge, but anyone outside was not able to do that. So that's when we decided to build a platform called CDAP. And that's what we are going to talk about today. So we started this company. It was prior to Cask. It was called Continuity. It was a proprietary platform that we were essentially building. September 29, 2014, when we open sourced this whole platform, we called it Cask Data Application Platform. And the company is focused on delivering a platform for building big data applications. Now, when you look at the number of components that go into making this big data, it's huge. And I'm going to be talking about that. So when you look at building applications on top of it, it's even harder. Everyone here knows the value is going to be accruing at the top of the stack where people are able to innovate and build applications, and infrastructure at some point is going to be commoditized. That's what happened with RDBMS, and that's what is going to be happening with Hadoop. But in order for that to happen, you need to have a common platform or a framework on which you can build data applications. That doesn't exist right now, and it's very different compared to traditional relational database evolution, because it's all open source now. If I am sitting in my garage and thinking of an idea for building something cool, I build it, I open source it, someone adopts it, it becomes popular, it goes into a distro. No one thinks about how it all needs to be integrated together. That's the biggest problem right now. And you have siloed technologies. When you look at a distribution, any distribution, Cloudera, Hortonwork, or any distribution, what you're expecting is when you open that box, you're expecting you to find an iPhone, right? You're looking for an iPhone experience, but what you find is the parts of the iPhone. And it's left to you to figure out how to stitch together to create that iPhone experience that you want to have. Is that what everyone wants to be doing? No. I just want to have the phone and be able to use the phone, and there are nice APIs on which I can build apps. That's how it should be. But it's not. It's not. You have to go through a lot of pain understanding every single component that exists out and be able to stitch them together in a very nice way. And there are manuals. There is manual for each individual component. There is not a manual for stitching all of these things together, right? One component will say how I can integrate with left and with right, but no one is going to tell how you can integrate it completely. That's a problem that exists, and that's the problem that we are trying to solve. When you look at the whole big data evolution, it started at a web scale at Yahoo, Facebook, Google, then many companies came in for doing EDW offloading, then science, and now the era of data application is picking up. There are many companies that are coming in this space right now, and you'll see a lot more. But as part of this whole ecosystem evolution, developers are the key, and they have been the most ignored population of all in this whole big data evolution. Now, it's a pop quiz. Can you hold a breath? Can you hold your breath and say all those technologies that exist in Hadoop? One breath, without missing anything. Give it a try. If you are feeling suffocated, don't do it. So that's the number of technologies, and you can see the way it started. It started off with only 2 things. I remember working with these. I can't remember working with all of these because I can't even remember what those are, right? So this is what makes Hadoop right now. I mean, everything is put under a single basket called Hadoop. It's a very loosely coined term, but actual Hadoop is this, even still. These are all the ecosystem components that are essentially surrounding it to support that different kind of applications that you can build on it. It's huge. It's huge. And if you have to build something sensible, you have to stitch a bunch of things together, which is extremely hard. If you look at it, these are not simple APIs. These are individual systems. And some are APIs, but some are not. Right? When you want to put all of these things together to just do a simple ETL, you can imagine the pain that one has to go through. It's very hard, right? And there are companies who do great and thrive living in this world because they have adjusted to the pain. But there are many companies or many people who want to make their life much simpler than this. And that's the experience that we are trying to provide as part of our platform. Now, with these kind of explosion, what ends up happening is any application that you build increases the complexity, right? You're stitching things together, you're trying and weaving technologies that are not meant to be stitched together. So it increases the application complexity. Now, the next thing that ends up happening is, because there are so many different technologies, you have to understand each individual domain. And it's very expensive. You can't be an expert at all. So you have to pick your poison pill, either red or blue, right? Or essentially you pick a technology and say, this is what I'm going to be expert at. And then once you gain expertise in that, a new one will come, and then you will have to start the cycle again. So there are many domains to bridge. Other than that, there is the business-specific domain that you would have to figure out how you can bridge the technology and get the technology into that specific domain. So that's another bridge you have to cross. So it's extremely hard to keep track of all of these different things that exist. Now, when you look at Hadoop itself, has anyone written a MapReduce job, like a bare-bone MapReduce job recently? Easy. It's very easy, right? You just have to write like 100 lines of code just to get to, can you run this, please? Right? So it makes it's not that you wouldn't want to do it, but it adds to the complexity, because don't think about when you write it the first time. Think about 2 years down the lane. Because you have space in the code, it's always likely that something will go in there, right? If the number of lines are reduced, it's so much easier that there is no place to put some hacks that always tend to go, right? So if you have more space, there is going to be hacks in there. It's natural. So a lot of boilerplate code basically opens up doors for that. right? And in fact, for every component that you integrate with, there is a lot of boilerplate code that you would have to use. Now, because there are so many different technologies involved, APIs are inconsistent. No one knows what API. So you guys probably use a lot of Kafka stuff, correct? Have you guys used 0.7 Kafka and 0.8 Kafka? They are entirely different, right? It's not that they're wrong, it's just that they are evolving. So you bear the burden of essentially adapting to those. So it makes it extremely difficult for someone to work with those. And not only that, it also means that if you know MapReduce, you cannot basically know, let's say, Flink or Spark. You would have to relearn all of those. They're totally inconsistent, right? And all this leads to no reusability. It makes it extremely hard to reuse something. If they're inconsistent, how would you reuse? And if you're in a different domain, how would you reuse? And all this comes down to lack of developer productivity. And this is exactly what we are trying to solve. All of these, we are trying to ensure that we can solve this in one platform called CDAP. Now, we have been at it for 3 years, and we have solved a lot of number of use cases within telco, financial institution, and SaaS companies. And this platform is evolving on a regular basis and trying to simplify and trying to solve all of these problems over a period of time. So this deck will be posted. You guys can look at what are the value propositions of CDAP and all those things. So I wouldn't go deep into this. So let's quickly get down into what is CDAP, right? That's the background. So what is CDAP? It's basically a platform that allows you to quickly and easily and quickly develop and deploy data applications, right? It provides abstractions, it provides services, it provides tooling and simplification that is needed for you to take build an application and be able to deploy that rapidly into a production environment. And these could be any ETL, any Hadoop solutions. You want to build a simple ETL, that's also possible. If you want to build a closed loop application like ad targeting, that's also possible. If you're looking to build fraud detection, that's also possible, right? And there's a lot of reusability. So in every application that I described just now, there is some notion of time series. And once you build the time series reusable component, you can just move them around between different applications, different storages, and that's what adds a lot of simplification and improvement to the applications that you're building over a period of time. Now, technically, it's an open source, integrated and a distributed and an extensible platform for building applications, right? And we'll go deep into the different components of it, and we'll basically figure out what are the different aspects that basically help you to do that. And I'll also show you guys an example of how the application looks like. So when you compare this particular stack to the traditional stack, we essentially fit exactly where traditional application frameworks used to fit. This is just to put a picture around where we sit in the whole stack, actually. So traditional stacks, you have hardware, OS, you could build native apps against kernels, but no one does that. I mean, there are people who do that, but traditionally not everyone does that. And you have an application framework against you build applications. Now, the same thing exists here. Now, Hadoop, you can consider that as a distributed OS. And to be very honest, at a very low level, it is. Because you have scheduler, you have resource management, you have coordination, you have storage management. All these essentially are critical basic building blocks of any OS. And this is just a distributed OS, that's what it is. It's a data center OS. People call it a data center OS. Now, for that, you need to be able to have a common framework, a framework that allows you to build applications. Any application that you want to build. And that's exactly where CDAP sits. Now, CDAP comes in 3 modes. You could be running it in-memory. You could be running it in a standalone. So in-memory is used mostly from an IDE perspective. So you could be running end-to-end applications of whatever you're trying to do, ETL or whatever that is, within your IDE and be able to test it functionally. This doesn't provide scale. This doesn't provide persistence. This provides persistence, but this doesn't provide scale. This is the only place where you can basically test for scale, right? So the whole idea here is you can do, CI test of your applications end-to-end or solutions end-to-end. Here you could be doing, Basically, we started off with this being used more from the demo perspective, but as we learned, our customers are using this to bridge the gap between the developers and operations. And I will show you how the operations stuff looks in CDAP. And the distributed mode is you just run on top of Hadoop. So from a CDAP perspective, you can manage data lifecycle, application lifecycle, and enterprise lifecycle. So all these three different lifecycles are managed within CDAP itself. These are some of the things that you would have to do on your own. With CDAP, you wouldn't have to. I could, if you want to ingest data into Hadoop, I could just create a stream and inject data into Hadoop. If it is real time, I could do that. If it is batch, I could do that. If I want to query, I go do the query. I don't have to think about another system that I need to integrate with. And I will show that. So if you go down a little, oh man, MapR is gone. So if you go down a little bit, we support the whole data ingestion to processing, to storage, to retrieving, and there are a lot of runtime valuable services that provide data consistency guarantees. That's the core of CDAP, essentially. When you look at what these runtime services, there are many different runtime services that are part of the system, and all of these runtime services run within Yarn itself. So from an installation perspective, CDAP is very little outside the cluster, but it runs within the cluster itself. And how it does is, as soon as you start CDAP, it goes and starts all the containers within Yarn, and it's up and running there. And if there is any problem, the services will be moved around. All that thing is being handled through Yarn itself. And datasets provide these reusable data access patterns. So if you can think of more like generics, right? Java generics. So these are patterns that are made available as libraries. You use them in your applications, and when you create an instance of it, that basically manifests itself into physical instances. And that's what dataset libraries provide. You can think them as more of like having examples like time series datasets, or you can build OLAP cubes on it. So essentially, these are all part of different datasets that are being presented there. And then we have a lot of capabilities around egressing the data out, so you can have services that are used to pull the data out and serve your end applications. Cool. So the functional architecture. So you can look at, this is going down a little bit deeper, but essentially you can look at, there are two ways, there are multiple ways of ingesting the data in. So one is you can push the data in, right? And you can push it in real time, you can push it in batch. You might say, yeah, Kafka can do that, Flume can do that. Yeah, we agree. Kafka can do that, Flume can do that. But can you basically use a single way of a single abstraction in which you can write whether it's real-time or batch data and be able to process them in real-time or batch in the same way? That is not possible. So you would have to set up a separate stack. You would have to make a decision about what happens if I want to start up with my retrospective analysis and I want to move to real-time. You need to have a whole different stack, essentially, to do that. With CDAP, you don't need to. You can create a single stream. You could be ingesting data in real-time and processing in batch. Or you could, if you want, whenever you want, you could move to real time. Okay, so I think I'll go over this quick and then get to a demo. So then you have many other ways of pulling the data in. So we have these notions of what we call pipes. And the whole idea of pipes is you could be pulling data from Kafka. You could be pulling it from any other sources that is willing to push. Twitter is one of those sources. Then we have notions of what we call DB syncs. So that allows you to periodically sync a database and make it available as part of the Hadoop cluster. These are mostly into the HBase tables, or they are also as part of the partition file sets. So you could be storing them in the partition file sets. And the last one, drop zone, is like SFTP stuff, but we have, So we have what is called edge side aggregations. This we have been working with AT&T Labs. And this is a technology that we have been working together for quite some time now. It's Tygon. As part of Tygon, there is this piece that can be put on the edges for doing real-time aggregations. And the amount of data that this guy has been, is capable of processing is amazing. You can put it on a router and essentially can process at line speed. And that data gets ingested too. So this technology is all integrated into this one single framework. And now you can have applications that could be in real-time batch, or if you feel like there is a common pattern occurring, then you can turn them into an adapter or an application template that we call. All that is being stored in the different data sets. These are different patterns. When you include a time series data set within an application, an instance of time series data set gets created. It's like you're using a map and specializing it to, like, let's say, a hash map. You specialize it and then create an instance of it. Memory structures get created. Here, actual HDFS, HBase, those kind of tables get created. So you can include them in real-time applications. You could include them in batch applications. It simplifies a lot from a user perspective. Now, all these are supported by all of the system services. So there are a lot of system services that are part of it. You have metrics, notification services, because a lot of things happen with the workflow, essentially, right? So if you're doing a lot of batch processing, you want to stitch together a very complex workflow. And you don't want your workflows to be stitched together in a way where there's a lot of polling happening. It's a waste of resources. So there is a first version of ESB that's built into CDAP that allows you to send notifications upon reaching certain thresholds of data, or you want to send notifications when some event happens in the system, so like it'll reload the data. All that is happening within the cluster itself. And there is a lot of metadata management, transaction services, data discovery, and security involved in it. And on the right-hand side, you see the many ways you can egress the data out, right? So you expose HTTP endpoints, you have JDBC, SQL, those kind of things that allowing you to retrieve that data out pretty fast. So in the spirit of time, I will make sure that I go to the code. I don't know, can you guys see this? Not very well, right? Okay, I'll try to talk through it line by line. So this is a very simple application that was written by a very early customer. It was a bank, and what they were trying to do was build a network analytics application. And the whole idea was they were collecting a lot of data using Wireshark from many different routers. They were ingesting this data in, and they were looking to figure out rule-based analysis to begin with. Then they wanted to do dynamic histogramming on top of it to figure out, real valued, are there any anomalies within them. They wanted to apply a lot of different things, and they wanted to maintain a time series of all of that. So they had already an existing system, right? They already had an existing system that was built. This whole application was built within a very short amount of time. You can only imagine, we went for a training. By the time we came out of the training for them, we had an application built for them that they deployed next day on the cluster, and it worked seamlessly. So this is that application. So the first thing that you need for any application when you think about for big data is being able to ingest the data in. So this is what is called a stream. So you define a stream. Stream is an abstraction that is built on top of HDFS. It can support real-time ingestion as well as batch ingestion. The data within stream is time partition, so you can essentially address the time ranges within the stream if you're doing it in MapReduce. If you're doing it in real time, it'll be very extremely at the rate it is which is coming in, it'll be processed. Now I want to do some kind of real-time processing on top of it. So you add something called a flow. So this is a Tygon flow. This is again the same technology that we have been working with AT&T Labs. It provides a lot of transactional guarantees. It has an imperative language support as well as the declarative language support. So you can use it more from a CEP style as well as more from an imperative data processing pipeline. Then these are different data sets that you can define as part of your application. Time series data set, here is a table, blah, blah, blah. And these are the services that you can define to retrieve the data out. So this defines the whole application. So you can look at it end to end. You can test this end to end. And that's the beauty of CDAP. You cannot do this. If anyone can show me how you can do this in Hadoop and consistently stitch them together, I would be amazed. It's hard right now. It's not impossible. It'll take time. It'll take huge, huge, huge amounts of time. And you would have to twist your brain many different ways to make this work, right? And then once you